Hey everybody, for the sake of this video, I want you to be able to look at a molecule and determine whether it's polar based upon its geometry, all right? And polar bond is typically between two different nonmetals, and they've got an electronegativity difference of this, or within this range, all right? Classic example is carbon monoxide. Carbon is 2.5 and oxygen's electronegativity is 3.5. So that's going to give me a difference of electronegativity of 1. So this is definitely going to be a polar bond, and it's going to be polarized towards the oxygen. So I'd have a delta negative and a delta positive. All right. All right. Carbon dioxide. So I'm going to have a similar polar bonds here and here. However, the fact that the carbon monoxide is symmetrical in that it's a linear molecule and these polar bonds here's carbon dioxide. These polar bonds exist along in a line. This symmetry makes this bond nonpolar. All right. Now, in terms of shapes, the ones that are symmetrical tend to be nonpolar, and the ones that are asymmetrical tend to be polar. It should say tend to be under this. I did the wrong thing. And what we're going to do is we're going to look at this within PhET, this modeling software, and figure out which one is which. Now this is two domains, so this is a linear shape as we just went over. This tends to be nonpolar. If I add another electron domain, like another bond, we'll start with 3 bondings. This would tend to be nonpolar because you can see the symmetry there. This is trigonal planar. All right. Now, if I replace one of these with a lone pair, I get the bent shape. This shape is not symmetrical. You can see it right there. These are down here. This shape will tend to be a polar shape. All right, so this is bent is a polar shape. Now I got rid of those, and now I'm into 4 electron domains. This is tetrahedral. That is very highly symmetrical. All right. This tends to be a tetrahedral tends to be a nonpolar shape. Now, trigonal pyramidal. This is ammonia. And this is going to be polar because if you look at the shape of it, all right, it's not symmetrical. I can have either end of these of this molecule could have an electron negative a chart like a gathering of electrons. Now this is water. This is a highly asymmetrical shape. All right. And this would be a polar shape. All right. Because it's bent. Again, this is bent. This is another polar shape. All right. So that's 4 electron domains. Now we're going to get into 5. We'll start with all bonds. This is Trigonal Bipyramidal. This is a highly symmetrical shape, and this shape tends to be nonpolar. If I replace one with a lone pair, there's my seesaw shape. This tends to be a polar shape. If I replace another with and I get my T shape, you can see that this is also a non-symmetrical shape. This would tend to be polar. If I replace another one, I go back to my linear shape that I had. This would tend to be non-polar, all right? Now, I want to go into my 6 electron, 3, 4, 5, 6. All right, this is octahedral. Octahedral tends to be a nonpolar shape. Nonpolar. All right? If I replace one with a lone pair and I get my square pyramidal, that tends to be polar. You can see this side is definitely different from that side. And if I replace one more, I get my square planar. That tends to be a nonpolar shape. All right? So here they are again, in case I missed them or in case they were hard to get down. Those are the shapes. All right, let me know if this helps. Bye.